Okay, sample size calculations. Given the confidence, and this is page 187 of the notes, so page 187. Given the confidence level and the standard deviation of the population, the sample size that will produce a predetermined margin of error can be calculated using this formula. Now, I don't like to use this formula because I don't have time to memorize extra stuff, but absolutely you can use it, but they're not giving this to you. You are going to have to memorize it. Okay, now I prefer to use algebra. I'm going to show this by algebra first, and I'll come back and do it by come back and I'll do it without memorization using the formula. I mean, by using the formula as opposed to the confidence level formula. So first off, with the confidence level formula, the confidence interval, this part of it is the margin of error. So the margin of error, or ME, and that's what that ME is, ME equals Z star, P hat, Q hat, and N. So an experiment finds that 27% of 53 subjects report improvement after using a new medicine. What sample size is necessary to create a margin of error of plus or minus 3%? So they're telling me instead of that we want to use a margin of error plus or minus 3, they want to use a confidence level of 98 and 27%. This is the old N, but this right here is P hat. That's a very important number. So P hat equals 0.27. ME equals, in this case, 0.03 for the 3%. We need to figure out what Z star is. And remember, we're just going to do a 1 minus situation here. So second var's inverse norm Z star, parenthesis 1 minus 0.98, close parenthesis divided by 2, mean a 0, standard deviation of 1 because it's a Z. And we end up calculating, and we end up getting 2.326. All right, so there's our Z star. So I'm going to start plugging in what I know. So if I have P hat, it's going to go here. That means Q hat, I should have written this down, because Q hat equals 1 minus P hat. So 1 minus 0.27 equals 0.73. All right, so now I have everything written out. There's my margin of error. I'll label that. Here's my Z star that we calculated over here. There's P hat that they gave us. This is the Q hat, 1 minus that, over N. Now what I end up doing is I end up dividing both sides by 2.326. So that goes away. And that gives me this value here. And now to make everything easy, I square the entire thing. So this number gets squared and that number gets squared. All right, so 0.03 divided by 326. And I'm going to square that number. There it is. It's squared. When I squared, this comes off and I end up with 1971. If I just put this over 1, I can see I have a nice little proportion. So basically, I'm multiplying 1 times that. That's not going to change, but I'm dividing by this third number right here. By the way, the 1971, I should have said, came from multiplying these two numbers. So 0.27 times 0.73. Now I'm going to divide it by this little bitty number, which is that 0.0016 number, divided by that value. And I get 1184.85, right? So equals 1184.85. Always, every single time when we're doing these, round up. Okay, this naturally rounds up, but this has been 1184.1, we still round up. So this is a situation where we always have to round up. Now, I said I would do this for those of you who want to memorize the formula. And I will say this, the formula is pretty easy to use. It's just you all have to memorize so much stuff for the online the test that I don't like it. I don't like having to memorize anything else. But if you're good at memorization, this is actually a fairly easy formula to use. So I'm going to write it down, z star squared, and then p hat, q hat, m e squared. All right, so that's our formula. Well, off to the side, we'd already calculated z star. So that's going to be 2.326. So 2.326. And we're going to square that times 0.27. We said q hat is 0.73. And our margin of error was 0.03. And we need to square that. And our margin of error totals the 3%. So if I do that, and like I said, it's not a difficult formula, it's just not one that I want to memorize. So 2.326 squared times 0.27 times 0.73. And then I'm going to divide it by 0.03 squared. 1184.85, round up to 1185. So once again, so this equals 1184.85, and that yields 1185. So if you're good with memorizing stuff, this might be very easy for you. If you're like me and have trouble memorizing and want to use some basic algebra, use the confidence interval. Okay? All right, so the next question is, what is the sample size is necessary to estimate the outcome of an election with a margin of error plus or minus 3% with 95% confidence? So they're telling us the margin of error is 0.03. And they're also, I should have said ME, margin of error. So margin of error equals 0.03. They tell me that the confidence level is 95%, so I can get the Z star from that. So let's calculate Z star real quickly. Second var's inverse norm, and parenthesis 1 minus 0.95, close parenthesis, divided by 2. Mean is 0, standard deviation 1, calculate. And I end up getting 1.96 for Z star by rounding. All right. But when I read this thing, I'm looking for P hat. I also have to find Q hat. But I need to figure out what's my initial proportion. Well, they don't give it to me. If they don't give it to you, this will always be 0.5. And the reason it's 0.5 is because that will give me the worst case scenario. That will give me my largest spread, my largest standard deviation. So my largest spread and largest standard deviation come with doing 0.5. And 0.5 times 0.5 is 0.25. Okay, so plugging into our formula, because once again, I like using the confidence interval. So this part right here is the margin of error. So 0.03 equals Z star, because this is my margin of error. This is my Z star. Here's my P hat and my Q hat. All right, and I've already previously calculated that. I divide both sides by 1.96, so this drops off. 0.5 times 0.5 is 0.25. And then I come around and I'm going to basically square, and 0.03 divided by 1.96 is approximately this value. I'm going to square both sides. So 0.03 divided by 1.96. Then I'm going to square that. Gives me this value here, which is what I have written here. And that also takes care of the radical. Well, I'm going to put this over 1, which means I'm basically multiplying by these two numbers because I have a nice little proportion, and I'm dividing by the third number. So 0.25 divided by my third number is that 1067.1. And what that rounds to is 1068. 1068. Now, go back, and for those of you who like memorization, so if you're good at memorization, this might be your way of doing it, equals Z star squared P hat Q hat margin of error squared equals, plugging in, 1.96 squared P hat 0.27 0.73 over 0.03 squared. So here we go. 1.96 squared times 0.27 times 0.73 divided by 0.03 squared. And I sure hope I messed up somewhere because that does not look right. Oh, 1.96 squared times 0.27 times 0.73 divided by 0.03 squared. And I'm still getting the wrong number. That's always, oh, never mind. 1 point, this is not point, I'm sorry, this is not that, this is 0.5. This was from the previous problem, so this should have been 0.5. So 1.96 squared times 0.5 times 0.5 divided by 0.03 squared. 1067.1. So N equals 1067.1. So N equals 1068. All right. And that's what we had written down previously. Okay, so that concludes this video. Thank you. In the next video, we're going to go through some multiple choice questions.